Hi GOH, this is Unit 6, Lesson 6, and today we're going to talk about the square. So square is something you probably did back in 5th or 6th grade. The square is interesting in that it is a parallelogram, it is a rhombus, and it is a rectangle. So basically the square has all the properties. A square is a quadrilateral. With 4 right angles, and 4 congruent sides. So basically it's like if you combined a rhombus with the 4 congruent sides and a rectangle with the 4 right angles, you would have a square. Based on this definition of squares, which of the following types of special quadrilaterals? Give a reason for why it is or isn't below. It is a rectangle. Why? It has 4 right angles. That's a definition of a rectangle. It is a rhombus. It has 4 congruent sides. And it is a parallelogram because all rectangles and rhombuses are parallelograms. Therefore, a square also has to be a parallelogram. So square is as well. All right, so square has all the properties, everything. Has many properties and many are used in the real world. Let's do a simple application that takes into account many of the properties of squares. Kimmy is designing a square garden whose diagonal is exactly 16 feet. All right, so I got a square garden. The diagonal is 16 feet. She would like to place fencing around the perimeter of the garden so that it is completely surrounded. If the fencing she likes comes in 12-foot long rolls, how many rolls will she need and how much fencing will be left over when she is done? Show all calculations that lead to your answer. Well, she's going to put fencing around the outside, so basically I'm looking to find the perimeter. A square has all right angles, so I can use the Pythagorean theorem. X squared plus x squared equals 16 squared. 2x squared equals 16 squared is 256. Now I'm solving for x, so I'm going to divide by 2. X squared equals 128. And to get x, I'm going to divide by 128. So basically each side is 11.31 feet. All right, perimeter then is just going to be 4 times 11.31. And you can leave all those numbers in your calculator so your answer will be more exact, but 45.25. Now the fencing, so that's your perimeter. The fencing comes in 12-foot rolls, so I'm going to take 45.25 and divide by 12. So basically I need 3.77 rolls. But you can't get 0.77 of a roll, so she would have to get 4 rolls. And they want to know how much fencing will be left over. Well, 4 rolls, I'm going to start writing up here. 4 rolls is actually going to be 48 feet. So if I take the 48 and I subtract that 45.25, I have 2.75 feet left over. All right. In the diagram at the right, square ABCD is drawn and the midpoints of its sides have been marked and connected with segments to form quadrilateral EFGH. Give an explanation for why EFGH must also be a square. All right, all the sides of a square are congruent. Whoops, let's write that down. All sides of square are congruent. And this is a midpoint, this is a midpoint, this is a midpoint, and this is a midpoint. So that makes this cut in half, this cut in half, this cut in half, this cut in half. So all those halves are going to be congruent to each other. So AE is going to be congruent to EB, is going to be congruent to BF, is going to be congruent to FC, is going to be congruent to CG, is going to be congruent to CG, which one am I up to? CG is going to be congruent to DH, is going to be congruent to HA. All right? Halves of congruent segments are congruent. Halves of congruent segments are congruent. All right. Now, a square also has right angles. So angle A, angle B, angle C, and angle D. Angle A and angle B and angle C and angle D are right angles. Therefore, they're all congruent to each other as well. So each of these triangles, let me highlight them. Each of these triangles will now be congruent to each other because look how it's marked. So triangle HAE is congruent to triangle EBF, is congruent to triangle FCG, is congruent to triangle GDH. They're all congruent by side angle side. And therefore, EH is congruent to EF, is congruent to FG, is congruent to GH. Let me do these all in a different color. These guys are now congruent to each other by CPCTC, right? And each angle of EF and FG, EFGH also measure 90, okay? So each of these also have to be right angles, and therefore that is a square. All right. Actually, how did I know that? If this is 90, these are 45 and 45, and this is 45, so that has to be 90 that's left over, and that would happen in every single corner. All right, as with parallelograms, rectangles, and rhombus, there are many different sets of conditions that are sufficient to prove that it's a square. The most obvious is simply showing that it has 4 sides of equal length and 4 right angles. So if you wanted to prove that something was a square, you would have to do the distance formula 4 times, and you would have to do the slope 4 times to show that it has a right angle. So that's what they want us to do in this first problem right here, which seems like really, really long, but it's not as bad as you think, because once you get the first one, the numbers are all going to be the same. So the distance of AB, I subtract the x's, 4 minus negative 4 squared, and subtract the y's, 8 minus 2 squared. So that's going to be 8 squared plus 6 squared, which is radical 64 plus 36, which is a radical 100, which equals 10. So every single side is also going to be 10. So when I do BC, I'm going to do 10 minus 4 squared plus 0 minus 8 squared. See how it's the same number, 6 squared and negative 8 squared. So right away, you know that is equal to 10. And side CD, so CD is going to be 2 minus 10 squared and negative 6 minus 0 squared. Again, negative 8 squared and negative 6 squared. But we already know 8 squared plus 6 squared is 64 and 36, which is 10. And side AD, okay, which is 2 minus negative 4, there's my 6, and negative 6 minus 2, which is my negative 8. So 6 squared plus negative 8 squared, which once again is 10. Okay, technically that makes it a rhombus. All 4 sides are congruent, and you just have to show that 2 sides are perpendicular to each other, forming a right angle, so you would just have to do the slope 2 times. This one asked us to do the slope 4 times, so I will do that. So I have to have the slope of AB I subtract the y's, that goes on top, and I subtract the x's, that goes on the bottom, so 6/8. And I find, I can reduce that. I don't necessarily need to though. The slope of BC, subtract the y's, that goes on top, subtract the x's, that goes on the bottom, -8/6. So you can see right now that they are negative reciprocals, so that is a right angle. And the slope of CD, which is -6/8, which again is 6/8 or 3/4. And the slope of AD. Okay, so definitely square is a little bit more complicated when you're doing it, but notice those slopes are, the opposite sides have the same slope because they're parallel, and the sides that are next to each other, the slopes are negative reciprocals. Okay. Each of the following sets of conditions explain why it's enough to show that a quadrilateral is a square. Think about what each thing is telling us. A quadrilateral with 4 sides of equal length, well, that right there makes it a rhombus, and it has one right angle. All right, so that makes it a rhombus, and therefore it's a parallelogram, because a rhombus is a parallelogram, and if one angle is 90, then all the angles are 90. So it's a rhombus because all sides are congruent, therefore it's a parallelogram because a rhombus is a parallelogram. And if one angle is 90, then all the rest. That's why I said back up above, if you just did the distance formula 4 times and the slopes of 2 consecutive sides, that would be enough. It's a parallelogram with the diagonals of equal length. Well, that makes it a rectangle. And remember, a rectangle is a parallelogram. And it has 2 adjacent sides of equal length. So if 2 sides that are next to each other are congruent, 2 adjacent sides are congruent, then that makes it a rhombus, or in this case a square, because I already know that the angles are right angles. So there's a bunch of different ways that you can prove that something is a square with coordinate geometry. No matter what you have to do, you're going to have to do 6 things. Me personally, I would just, even though the distance formula is a little annoying, I would just do the distance formula 4 times and the slope formula twice. So if a parallelogram with perpendicular equal length diagonals. So it is a parallelogram. If the diagonals are perpendicular, that makes it a rhombus. And if the diagonals are equal, that makes it a rectangle. Therefore, it's a square because all sides are congruent. Because I know it's a rhombus. And it is, all angles are right angles because it's a rectangle. If it's a quadrilateral whose diagonals are perpendicular bisectors of one another and one right angle. So if the diagonals are perpendicular, that makes it a rhombus. If they're bisectors, well, that makes it a parallelogram. And if it's a rhombus and it has one right angle, then that makes it a rectangle. So as soon as you see that it's a rhombus and a rectangle and a parallelogram, then you know that it's a square. Okay, and we will practice our square